All right, let's talk about a huge challenge for basically any company out there: customers leaving. In this explainer, we're diving into the world of machine learning to see how we can predict this. Specifically, we're going to watch a tale of two models as they go head-to-head on this critical business problem. I bet most of us have at some point, right? You see a better deal, you get frustrated with customer service, and poof, you switch. Well, that one little decision you make is a massive, massive deal for these companies.
And that right there is what the industry calls churn. It's more than just a buzzword. It's lost money. It's a potential hit to their reputation. Honestly, it's a constant fight for survival. So you can see why being able to predict it is an absolute game changer.
So, to figure this out, we're not just crunching numbers. Think of it like this. We're bringing in two different kinds of data detectives. Each one has a completely unique way of looking at the evidence to figure out who's about to walk out the door. So let's meet our detectives. In one corner, we have the classic, tried-and-true investigator, Logistic Regression. And in the other corner, we have the highly sophisticated, powerful specialist, the Support Vector Machine, or SVM for short. Now, this is where it gets really cool because they don't think alike at all. Logistic regression is like a bookie. It looks at a customer's history, their contract, how much they pay, and says, okay, I'd say there's a 75% chance this person is going to leave. But SVM, it's more like a cartographer. It plots every single customer on a giant map and then draws the boldest, clearest line it possibly can to separate the churners from the non-churners. Two totally different philosophies. But before any detective can solve a case, the scene has to be prepped. And in data science, this prep work, it's not just important, it's everything. And this is where the real story of our two models actually begins. So here's our pre-investigation checklist. First, you got to fill in any blank spots on the records. Simple enough. Second, you have to turn words like male, female, or month-to-month contract into numbers the models can actually understand. And then there's the third step, the one that is absolutely crucial for our comparison today: feature scaling. So what is feature scaling? Look, imagine you're comparing customer tenure, which could be like 72 months, with their monthly charge, which might be $80. To a machine, 72 and 80 look pretty similar. But what if you look at their total charges, which could be in the thousands? Suddenly, that feature looks way more important just because the number is bigger. Scaling fixes that. It puts everything on the same yardstick, creating a level playing field. And this is the million-dollar question. Does this cleanup step, this level playing field, matter the same way to both of our detectives? You might think so. But the answer is a huge, emphatic no. And here's why. Our bookie, Logistic Regression, doesn't really care about the raw numbers that much. It's looking for relationships. But our mapmaker, SVM, its entire world is built on distance. It draws that boundary line by measuring the space between customers. So if one feature, like total charges, has a massive scale, it completely warps SVM's perception of the map. It's like one mountain is so tall, it blocks out the view of everything else. It makes the model blind to other important clues. Okay, the scene has been prepped, the data is scaled, our detectives have done their work. Now it's time for the big reveal. Let's see who cracked the case. This is the moment of truth. After all that careful preparation, making sure everything was just right, which of our models turned out to be the master sleuth at spotting customers who are about to churn? Now, to judge them properly, we need a toolkit. Precision asks, of all the people we accused, how many were actually planning to leave? Recall asks, of all the people who did leave, how many did we successfully catch beforehand? And the F1 score, that just gives us a nice balanced score of both. And here are the numbers. Now, while the exact values might change a bit depending on the run, you often see a pattern emerge. Once the data is properly scaled, our SVM model tends to edge out the competition, particularly in that balanced F1 score. It just shows a better knack for balancing the don't accuse the innocent with the don't let the guilty get away problem. So why does it win? Well, SVM has a secret weapon called the kernel trick. Put simply, while logistic regression is stuck drawing straight lines, SVM can draw complex, curvy, and winding boundaries. It's like it can see the data in 3D, allowing it to find these really subtle, nuanced patterns between who stays and who goes that a simpler model just can't see. So, okay, what's the big lesson here? Is it just use SVM instead of logistic regression? No, not at all. The real takeaway is something much deeper and more important than that. Let's just remember why we're doing this in the first place. This isn't an academic exercise. A good prediction model gives a company the power to be proactive. They can stop guessing and start making targeted offers to specific people they know are at risk, and hopefully save that customer relationship before it's too late. So if you remember anything, remember this. Knowing your model, how it thinks, what it needs, is just as important as picking it. Data prep isn't just a chore, it's a core part of your strategy. And that sensitivity SVM has, it's not a flaw. When you handle it right, it's actually its greatest strength. At the end of the day, there is no one best model. There's only the right model with the right prep for the job at hand. Ultimately, this whole thing is about that relationship between our tools and our data. So I'll leave you with a question to think about for your own projects. What assumptions are you making about your data before you even start? Have you really set your detective up for success? Thanks for joining me.